This video will be an example for section 1.5, factoring polynomials. We'll do an example of factoring by grouping. Let's start off with the polynomial 6x squared minus 19x minus 11. In this case, we'll use the labels a, b, and c for the coefficients. So we have a equals 6, b equals negative 19, and c equals negative 11. If you remember our process for factoring by grouping, we want to find a pair of numbers that multiply to a times c and sum to b. So first we have a times c. In this case it's negative 66. Let's list the factors of ac. And we want to find something, a pair of factors, such that the sum is b, or negative 19 in this case. So let's also write down the sum of the factors. Okay, to start off, we have 1 and negative 66. These sum to negative 65. We could also do negative 1 and 66. These would sum to 65. Let's see, we also have 2 and negative 33. Those sum to negative 31. We could try negative 2 and 33. Those would sum to 31. Let's try 3 and negative 22. That gets us negative 19, which is what we want. Let's keep going and see if anything else would give that. We could do negative 3 and 22. That would give us 19. And the other possibilities are 6 and negative 11, or negative 6 and 11, and those would give us negative 5 and 5. So the one we want, the pair we want, is 3 and negative 22, because those give us a sum of our value b, which is negative 19. Okay, so we have p equals 3 and q equals negative 22. You could be asking, does it matter which one we pick to be p and the other to be q? And no, it doesn't. I'll actually show you that we get the same answer whether we flip the labels. So let's first do it with p equals 3 and q equals negative 22. Following the formula that the book demonstrated, we can rewrite our polynomial as 6x squared, and then here we split the bx term into px plus qx. So we get 3x minus 22x. And then we have our last term minus 11. Now we factor out the GCF of each part that I'm underlining. So let's see, the GCF of 6x squared and 3x would be 3x. And we're left with 2x plus 1. Okay, and then the GCF of negative 22x and negative 11 is negative 11. And what are we left with? We're left with 2x plus 1. Great. So we rewrote our polynomial, and then we factored the GCF out of the first two terms and then the last two terms. The final step is to factor out the GCF of the whole thing. So notice that both terms have a 2x plus 1 in common. So we can factor that out, and we're left with 3x minus 11. And there's our factored form. Now let's try it if we did p equals negative 22 and q equals 3. So when we rewrite our polynomial, we would have 6x squared minus 22x plus 3x minus 11. Okay, and again, we factor out the GCF of the first two terms and then the last two terms. So here we would get 2x, and then we're left with 3x minus 11. Great. And then for the second, the GCF of 3x and negative 11 is 1. They don't have a common factor besides 1 or negative 1. So let's just keep it as 3x minus 11. Good. Now we can, I'll draw a line in the middle so we know this is a different version. Now we factor the GCF out of the whole thing. So both terms have a 3x minus 11. So we can factor that out, and we're left with 2x plus 1. So we see we get the same answer for our factored version. Let me know if you have any questions on this example. You can write them down and bring them to class.